You're watching the Weiss channel. Today, I'm going to talk about standard deviation. Standard deviation. That is like margin of error. Find the margin of error in polling, right? If you say someone has a 5% polling lead, but there's a 7% margin of error, well, that's not good. But a 5% lead, but there's a 3% margin of error, that's pretty good. You're doing okay. Anyway, standard deviation is calculated by this formula. What is all this? These are Greek letters. This one is a lowercase sigma. That is an uppercase sigma. And that is a mu. All right? So lowercase sigma stands for standard deviation or margin of error. N is the population size, the number of people you're surveying. X, each X is each value from the population, and mu is the mean. For example, all right, here you have a group of numbers, 15, 23, 27, 18, 26, and 16. Find the mean first. Add the numbers together and divide by how many numbers there are. That is my mean. So now, after you get this number, you're going to take each individual number and subtract the mean. 15 minus the mean, 23 minus the mean, 27 minus the mean, and you square it. So each number minus the mean squared, and you come up with these numbers. And frankly, it's fine if you just round the numbers. You don't have to get exact. If you just put, this would be 34 or 4.7, 38.1. You can round the numbers, okay? You add them all together, and then you divide by how many numbers there are. There's 6 numbers. So those numbers added together, divide by 6, and then you take the square root of that number, and it gives you your standard deviation. Okay? Here are 7 numbers, okay? And you find the mean, all right? And once again, you take each individual number, subtract the mean, and you square it, okay? Once you square each difference, add them together, divide by how many numbers there are, take the square root, and that is your standard deviation. By the way, why are some standard deviations like this one is less than, say, 5%, and this one is almost 10%? What's the difference? Well, do you see these numbers? These numbers are between 15 and 27. There is a difference of like 12 numbers from the lowest to the highest. That's the range, it's like 12 numbers, right? But over here, look at this, all right? Here's numbers like 47, 52, 59, 40s and 50s, except for one number, 78. 78, that's a difference of like 31, right? So when you have bigger differences in a wider range, you're going to wind up with a bigger standard deviation. You've been watching the Weiss channel.